What's up? What's up? Welcome back to my live stream. Tonight I'm back to doing coding challenges. Tonight I'm doing a medium problem called letter combinations of a phone number. So this is supposedly asked by Amazon, Facebook, and Google. And basically it's like to find all the different letter combinations on a phone number dial based on a certain phone number that's 2 through 9. So I'm gonna be trying to work through this problem tonight. Appreciate you people joining. I think I'm live everywhere, so let me know if anything's wrong with the sound or anything like that. But other than that, I'm just about to jump right into it. I'm not about to waste any time, so appreciate y'all joining. Tonight we're working on the problem from Leetcode.com, medium problem called letter combinations of a phone number. Given a string containing digits from 2 through 9 inclusive, return all the possible letter combinations that the current number could represent. Return the answer in any order. A mapping of digits to letters, just like on the telephone buttons, is given below. Note that 1 does not map to any letters. So yeah, just a voicemail thing. This reminds me like the old cell phones and stuff we used to use. And the answer needs to be an array of arrays with all the combinations. So if you look at digits 2 and 3, then the combinations are A to D, A to E, A to F, B to D, B to E, B to F, and then C to D, C to E, and C to F. So basically it's just how you would think about it. Like, what are the possible letter combinations if you were doing back in the day when, if you're old enough, back in the day when we first got cell phones, that's how we used to text, is like press the button 1, 2, or 3 times to get a certain letter to text some sort of text message, which is really crazy to think that that's how we used to do it. But we all actually got pretty good at that for those that were around back then. But this is basically just find all the possible combinations that you could make and put them in a list of arrays. And then of course, if the digits are 0, then you get an empty array, which is like an edge case. And then if it's 2, then you just get A, B, and C. So, and then the digits has to be greater than 0, less than 4. So what is digits? Greater than 0, less than 4. Okay, so I guess it'd never be longer than 4 digits. That's interesting. I would think they would do like an infinite problem, but I guess with combinations, I guess it can get out of control. And then digits is in the range 2 through 9. That was already stated in the problem up here. So that's the problem statement. But we're about to jump into it. So how I like to do all of these is back in the day with the cell phones. How I like to do all of these is thinking through the problem in my head. Either with pen or paper or just with my head. But like, how would I solve this in my mind? And just like I was talking about, I feel like I would need to, for whatever my first number is. So let's go with example 2, 3. My first number is 2. I know I need to try. I know my first part of my combinations, I would at least have 3, A, B, and C. I would have a string that starts with at least A, B, and C. And even when I start with A and go to 3, I know that I have A, D. I know I have A, E, and I know I have A, F. And then if I move on to B, I know I have B, D, B, E, and B, F. And if I move on to C, I know I have C, D, C, E, C, F. So it's like basically going through each of these and then trying all the combinations of the next number. And then if you go to 4, trying the combinations on all of those combinations to the next number. So once you start getting the combinations type things in a problem, it's something you'd have to study, but the intuition will eventually tell you that you need to use like some recursion, some sort of recursion, depth first search or breadth first search. But you're going to need to use some sort of recursion to do this problem effectively when it comes to combinations. Usually, I mean, that's the easiest way to do it. It's possible that with breadth first search, you don't have to do any recursion. So you probably could figure it out with that without recursion exactly. But you're going to need to do some sort of like looping or recursion to solve some sort of combination type problem. So what I'm thinking is like for each letter, for the next number, I want to loop through every combination and add it to that current letter. And on each combination, I basically want to recursively add the letter to it, and for each number, add the 3 letters to the combination and go into a different function with each combination, if that makes sense. It's hard to explain it, but when I do it in code, I think it'll be easier to understand. But basically, I want to recursively loop through each number here, and then as I go to the next one, I want to basically call more functions like almost exponentially to do my calculations. And then I want to once I get to the point that my string that I've built equals the length of the phone number input, so like 23, once it equals 23, then I want to stop there and add it to this list of items. So I basically want to say for number 2, start with A, B, and C. So that's already 3 things I have. And then call recursively another function for number 3 and try each A, B, and C also with D, E, and F. So it's kind of hard to explain, but I'm going to jump into it, and hopefully it makes a little bit more sense when I jump into the code over here. So like I said, intuition for this problem is to use some sort of like depth first search, breadth first search, or use some sort of recursion to simplify the problem of trying all these different multiple cases that you need to try. And so the first thing I'm thinking about with this is, how do I know what the combinations are for each number in code? So how do I translate this this keypad to code? Because I need to operate on this keypad, I need to know what 2 letters equal to 2. So how you can do that is create a map. And so what I'm going to do is, I guess I can do it inside of here and say number to letters. Just going to make a new map called number to letters. And I'm actually going to maybe put this outside of here, like down here, if I can. And no, I'm going to do it inside of here actually, because I need to add some stuff to it. So numbers to letters, I want to set, so 2, I want to set that to an array of letters, A, B, and C. So basically I'm copying my keypad over here. I'm copying the keypad to an in-memory map of so 2 equals to A, B, and C, if you see on the keypad. So I basically need a way in code to know what the keypad looks like. And so this is a way to do it. A lot of problems that you do on here will have this sort of concept. So if I go, so I'm going 2 through 9 based on the problem definition. 6, 7, 8, 9. So I'm done there. And A, B, and C are the first ones. D for 3 is D, E, F. Let's see what it is for 4 is G, H, I. So for 4 is G, H, I. For 5 is J, K, L. For 6 is M, N, O. For 7 is P, Q, R, and actually S for this one too. And then for 8 is T U V T U V. And then W X Y and Z. So yeah, W X Y and Z for that. And so now I have I have in-memory map that matches the keypad. So now I can start operating on the keypad, because without that, you can't do the problem, because you got to take this picture into code in order to do the combination work. So now that I have that in here, the other thing I want to do is I want to probably handle this edge case over here. So there's an edge case that says, yeah, if digits is null or digits is empty, then just return empty output. So I'm going to go ahead and just handle that edge case. So if digits, let's see, yeah, if digits is this, then I'm just going to say that, which I don't know, maybe my rest of my code will just handle that, but this will get me out really quickly. And then from here, I'm gonna what I like to do is go ahead and handle my results ahead of time. So I know I need a list of, just to keep my mind in order, I know I need a list of arrays. So I'm gonna say you can create a tree and do binary search on it instead of doing brute force. Yeah, I think I can do that. But this is I'm not searching for anything, so I wouldn't use binary search. I'm looking for the combinations of a phone number. So it's not a searching problem. Actually, it's a combinatory problem, however you say that. So I actually need to use some sort of, so I'm not using brute force though. So that, I mean, I get what you're saying, but I shouldn't be using brute force, but I'm not using brute force. I mean, I guess you could kind of call it a brute force thing. I mean, you kind of have to, like, there's no way, if a question is asking you to find all the combinations, then you kind of have to find all the combinations. I mean, you have to look at every single number, but yeah. So here I'm going to do, I like to do my results first, but I need something in between here to basically solve the problem. So what I want to do here is, like, I'm going to call it depth first search. I'm just going to call it DFS, but I want to basically recursively call a function to build a combination set, to start driving my combination set. So the first thing I think I want to pass in is digits, and I'm kind of going off the wing here. The second thing I want to pass in is, like, my current string, my current combination string, which right now is blank. And then the third thing is my results, because I need to update results as I go. As I keep calling this, I'm going to update results over and over. And so for that, I need to actually create another function. I'm going to pass in digits, and I'm going to call this current. That's like my current string, current combination. Or maybe I can call it current combination. And then my results, which is where I'm going to put my results in. So what do I want to do in this, like, depth first search? And it's not really a search. It's more or less like a, you can use the algorithm for, like, a depth first search to search a combination. So I really could call this, like, I don't know, like set combinations or something like that, or find combinations or something like that. So, which I might change the name of it actually. So, yeah. So in the depth first search, I'm passing in digits, current combination, and results. So how do I know that I'm done? So when I look at when I look at a recursive function, I try to focus, instead of trying to focus on all this like crazy stuff of like you're calling this inside of this and calling this inside of this, I try to focus on what do I need to do at each iteration that I'm calling this. So the first time I come into this, I'm going to come in with digits. This is blank, and this is the empty results. So the first time I come into this with, let's say, the problem we're starting with is 2 and 3. The first time I come into this, I want to check if I'm done. So I want to check if digits.length equals to current combination dot length. So as you see with the answers here, once the current length equals the digits, a combination length equals the digits, then I'm done. And I need to enter it into my array, my results array, actually. So here's results, and I'm going to push in the current combination, and I'm going to return because I'm basically done at this point. But I need to do more stuff here because I may not be done. So what do I actually need to do in this function here? And so the first thing I need to do is I need to look at a current character. What's my first character? Is 2. And so I need to basically look at, let me see, I'll call this current digit or something like that. And then this is from digits, and this would actually be the length of current combination. So the length of current combination currently is 0. So that means I'm going to get the first thing out of digits. So my current combination is like a running sum, or not a running sum, but a running string. Yeah, I'm using recursion here. But yeah, it's a running string of the current combination. And somebody just asked for an update of what the problem is. The problem is letter combinations of a phone number. So basically I have a keypad and I need to find all the combinations of strings that are possible from an input of digits. So for numbers 2 and 3, these are all the possible text messages you could send. Like if you had an old Nokia phone or something, and you just had 2, if you just only could use the numbers 2 and 3 in this order, then these are the possible things you could text. And so I need to do that for any type of input. So like if I'm in 2 or 3 up to 4 digits, I need to be able to handle. So anyway, so I'm jumping back over here to the code. And where was I at? Yeah, so basically I'm doing recursion, and I'm just calling it this, but it's just a recursive function that is basically getting a new combination or going down these recursive paths of combinations. So I need to find it. What is my current digit I need to focus on? In the digits, which is a string, I need to get the current combination. I need to get the next digit to work with based on the current combination. And so the current combination, if it's 0 in length, I need to get the first digit out. And that's what I would be doing in my first call here. The length is 0 because it's just an empty string. And so I will be getting, in the case of 2, 3 digits, I will be getting 2 out. So this would equal 2. And then what do I need to do? Well, like I said, I need to work on all the combinations that are for 2. So if this is 2, how do I get the combinations? Well, that's why I built this thing up here, this map, so I can get the combinations for 2. So what I can do down here is say for, and this would be letter of number, this is my map, numbers to letters, get current digit. I spelled that wrong. Wait, why? I need to put this down. Why is this sitting up here? Yeah. So yeah, basically I'm getting A, B, and C for 2 because 2 is my current digit I'm working with. And I'm going to loop through every letter A, B, and C inside of here. And now once I look at A, B, and C and put that, I want to have current combination now be A, B, and C. So I want to call DFS my same function recursively. I'm going to pass in digits again because I don't care. It should be the same thing. And I want to basically say current combination plus the letter. And then I want to pass in results because I'm just keeping results is an object that I'm just passing through by reference. And why is this crap in the way, man? Let me add some space down here so y'all can see. Yeah. But yeah, so I hope this makes sense. Like, please ask questions if it doesn't make sense. But it's basically, I'm calling this function again, but this time I'm adding the current letter and I'm looping through all the possible letters and I'm calling this 3 more times with every possible, or 4, based on the map. So I will call the function with each letter again recursively. I take whatever my current string is and I add whatever the next letter is from current digit, the next possible letters, and I call this 3 times. So because I'm looping through calling this 3 times, I'm like fanning out the possible combinations of strings as I build this current combination string. So every time this function gets called, current combination string gets larger and larger for all these different paths, and then it terminates once a current combination equals the length of digits. I don't need to go past that because I'm already done with the digit string. And actually, I couldn't get another current digit if the current length is too long. So, yeah, that kind of makes sense. It definitely makes sense, but it's a little hard to understand. And somebody said, why is current digit declared as let if it's not getting reassigned? Yeah, I guess I could call this a I guess I could call it a constant. I typically don't call something a constant unless it's like an actual like constant value though. But I don't know. I think that's probably arguable for sure. Because I don't even know if that would work. So yeah, I don't know. Because I'm setting another variable to this. I kind of like using let unless it's like an actual constant. Like if I'm putting like 2 here, then I probably would be like, I don't know. But you're probably right. So anyway, but yeah, so I get the def first search here. And I actually think this would work if digits was, so what happened with digits was just this. The digits would be, it would have 0 length equals 0 combination length. Yeah, so it would be 0, 0. And I would push this into, no, because yeah, I would push this into it. So no, that's not right. Because I don't want to push that into it. So yeah, because yeah, if it equals this, and I will push the current combination into it. And for that one, the answer should be an empty string. So I actually do need this this case here, and I'm just gonna clean this up a little bit. Do it like that, and I'm gonna like pull these together a little bit, make them a little bit more clean. Yeah. So, but I think this looks good. So what I want to do at this point, I think I'm done. What I want to do at this point is, a lot of times in an interview setting or even on your own, you want to just walk through the code yourself, make sure it works. And you also want to try an example in your head or on paper. But in this term, on paper, I mean, I can just use like comments. So I can say, what's digits equal to? I'm going to say it's equal to 2, 3. I'm going to try that case out. What is results equal to? It's going to start off as an empty string. And then what's this current combination thing equal to? And so this is recursive, so this might be a little difficult to do recursively. But I'm gonna try. I'm gonna try to do it. So and I actually might need to put this actually down here. It's a little easier to see down here what's going on. Cause like here, this is pretty straightforward. I have this set up. This is my exit case for the empty string, and then I'm doing my first recursive call here. And then it's gonna have digits of 2, 3. It's gonna have a blank, which I have here. It's gonna have results, which is just an empty array. So yeah, do you need an early return for that? Yeah, so here, that's the edge case here. That I got an early return for. So yeah, good call out there. And let's see. What question is this? Somebody asked what question it is. This is on Leetcode. It's letter combinations of a phone number. So you're basically trying to find, for each of these numbers 2 through 9, you're trying to find all the possible letter combinations for a certain phone number. And the phone number can be like one. It's like not a real phone number, like a short number of digits, like 2 or 3 or 1, 2, 3, 4. Basically find all the combinations for a certain number of digits. But I'm almost done with this. I'm just testing it out. So yeah, here I set up this. I think this looks right. This is 2, 3, 4, 5, 6, 7, 8, 9. I'm actually testing or reviewing the code and making sure everything looks right. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Because you can make a mistake here and it just screws you up the whole time. If digits is... See, I had a mistake here. Digits... wait, no, that's right. I could say digits length equals 0. Would probably be... I actually like that better. Digits.length equals 0, then just return empty array. Then set up results, and then go into here, digits. Yep, so that looks right. And then here I check digits length, and it can never be an empty array if it equals the combination length. Then I push this or I skip this and I return there. Get the current digits based on the length of this. So it would start with 0 because the length of current combination would start with 0. And then, yeah, this probably could be a constant. No, but they can't. Well, I think it can be a constant. What happens if you mutate a map, set it to a constant, but you set it? Can you still set it? See, I don't like that. If you set, I don't like, if I think JavaScript does let you do that, but that's weird because like, it's a constant, but then you still can like mutate its inner workings. So, I don't know. And this, so I'm gonna try it. I'm gonna set this to a const. And I'm gonna set this to a const. I'm gonna see what happens. Since somebody said don't be afraid of constants. Yeah, I'm gonna try that out. So I'm assuming this one shouldn't be a constant, but I don't know. So yeah, put that as a constant. What else do I want to do? Yeah, so now I want to just try this out. Yeah, this looks right. Letters of, number to letters, get current digit. And then I'm adding the letter that out of my combinations to the current combination to build upon the new string. So yeah, that looks right to me. So if with 2, 3, I would come in here, I would skip this because digit length is longer than current combination length, so it's not equal. I would come here and get my current digit based off the length of this, which is 0. So I would get 2 because it would be digit 0. So I would get the first thing in there, which I actually want to make something for current digit. So I get 2. Then numbers to letters, that would give me A, B, and C. So that means I would def first search or recursively call this function with plus A, plus B, and plus C. So I would already call this with A, B, and C. So then when I would come in here the first time, I would have A. and it's gonna go. And it kind of is depth first because it's gonna go like straight. It's gonna go straight down like the first path, just like you see here in this answer. It's gonna go down to A's first, and then it's gonna go down to B's, and it's going down to C's. So it's kind of like going like down in like depth first before it's going horizontally, if that makes sense. So yeah, so then I would have A, and then the current digit is, yeah, so I would come back in here with A, and then is digits equal to the length? No, it's still not. It's just A, so I skip that. And I would get my current digit this time would actually be 3 because I have a length here of 1. So I would get digits at index 1, which would be 3. Current digit is 3. Then now for 3, I'm going to call this recursive. I'm going to get the letters out of the numbers to letters. This time it is D, E, F. And so I'm going to call this 3 more times where current combination equals A already. So then when I call it again, I'm going to call this 3 more times. But the first thing I do is do D. And so I'm going to call this again with current combination plus the letter, which is D. So I would get AD. And then my result is AD. So I'm not going to go through all this because it's hard to go through recursively, but I can see that I'm starting to build my current combination stream properly, because once I come back into this again for AD, these equal now. Digits length and current combination length equal, and now I'm going to push it into the result as my first result, AD. And I'm going to terminate this recursive call. And so now I'm done with this, and now I kind of like bubble back up to the AE at that point, and then I would terminate it again. So then I would bubble back up, and this would be AE because it would call the next recursive function. The current digit would still be 3, and then I would hit this again and add AE. And so I'm not even gonna go through all this, but I can basically tell based on my logic that I'm gonna get the right answer. I can at least stop here because I feel that it's going to it's going to work, or it seems like it is. It may not. And I'm not saying that it will, but you have to kind of have a cutoff point, especially if you're in a time crunch, like an interview setting where you're in a time crunch. You have to kind of like make some educated guesses, but this is looking good to me. So I'm going to run it. And wait, the first thing I do want to talk about is the time and space complexity. So I think for space, it's constant. The only thing because I'm storing just this this is not based on my input of digits. This is just based on a fixed number 2 through 9 and a fixed number of letters. So this is like using constant space. It's not based on some like infinitely increasing input or potentially infinitely increasing input. And as far as the time complexity, I'm actually not really sure. So if anybody knows what the time complexity of this algorithm would be, you can let me know, because I would think that it would be this one's pretty complex of what this would be, because I know I got to go through every digit, so that's n. And so I would guess that it would be n. Yeah, I'm coming in here and then I'm doing for every digit. Seems almost like n. I don't know. Yeah, this is a complicated one. So yeah, big O of n for the space complexity, or for the time complexity. I don't know, man. It seems like it would be more than that, because I'm not just looping through the digits. I'm recursively calling for every combination here. But so I would think like n times like k or something, where k is like something to do with these number to letters. I'm going to look that up when I'm done, or what that is, because I honestly don't know what it is. This one's a little bit more complex. But yeah, Somebody said, you have any experience web scraping? Yeah, I did. I was trying to get an iPhone one time, and I was web scraping Apple's web page to try to find when the iPhone was available, when the iPhones were really hard to get on those first days. And then they had an API that I found unofficially, and I started using that. So, and then I think I did it for when I was trying to get an Xbox and PlayStation 5. I was scraping the Target web page to look for the on the PlayStation page to look for if it was available, which was a cool project. But I'm going off topic, man. So let me just go ahead and just start run this and see what I get. So it looks like I have an issue here. And this I probably just named this wrong. Let me see. Number 2. Oh, I know why. So I have to either pass this in or put it outside. So I'm actually going to put it outside. So does anybody know what I did wrong there? This actually needs to, I'm going to put this like down here. I don't know if this will work. Let me think. This is a constant, so it should hoist. Yeah, we'll see though. Yeah, it did. So like I can move this down here. Once this will execute outside of the function, this will execute immediately based on how Leetcode runs it. This hoist, and then I can basically use it in both of these two functions. So the problem was that I had it inside of the functions. Somebody said, man, I code all day. I have zero motivation to code for fun. I wouldn't say this is for fun. I'll say this is more for learning. I mean, I like doing these problems, but I don't like them enough to have them for fun. And what problem is this? This is letter combinations of a phone number. Basically, for some sort of phone number, some short phone number code, I need to find all the possible combinations. And basically, I am done. Yeah, I got all the right answers for the 3 use cases over here. I'm gonna add one more use case, test case. I'm gonna add like 1, 2, 3, 4. And then I'm going to run that, see if I get the right answer for that. Oh, I'm tripping, see? I didn't even do my test case right. 1 is not a valid number. Got to be 1, 2. 1 is not. 1, it hits the voicemail button on the keypad, so that's not right. So somebody said, wait, you don't need to do backtracking. You actually don't. Yeah, I thought that too when I first did this problem. This problem looks like you know how like in backtracking problems you would start doing some sort of backtracking right here. This problem is actually more simple. Like you don't actually need to backtrack because you're just trying to find all the combinations. There's no criteria that will cause you to need to backtrack because you're just trying to find all the combinations. Somebody said try negative input. So negative input isn't valid here. It has to be 2 through 9 on this keypad. So I actually think I'm straight. I'm gonna try it against the Leetcode, all of the Leetcode submissions and see. Yep, it worked. So it didn't beat that much of the runtime, but the memory is pretty low. But the runtime only beat 18%. So I usually like to be around like 50%, but I'm cool with it. I think it would pass in an interview setting or in a setting where if I had to do this for my day job, it probably would be okay. In the scenarios that we're used to. I'm trying to think if there's anything I have in here that would slow me down. Yeah, I don't know. Somebody probably figure out how to do it faster by doing a different solution. So yeah, what is this website? This is Leetcode.com. This is one of the most popular coding challenge problems that a lot of bigger tech companies use. Some smaller ones, some medium size, and some use it too. But like if you're trying to get a job, like a lot. If you're trying to go for like FANG, like Facebook, Amazon, Apple, Netflix, Google, they're gonna ask these questions, these type of questions. They're like riddles to me. I have my own opinions about them. That's why somebody said, "Are you doing this for fun?" Like, nah. I'm just doing them to stay sharp. Right now, I'm not like interviewing or anything like that. But you have to stay sharp with these, and I have to do interview. I have to give people interviews too. The industry's kind of shaky right now, but I have to do interviews. I have to give these problems to people that I interview. My company does these type of problems in the interview. So I don't want to make this too long, but yeah, it looks good, man. Looks like I'm gonna submit it one more time. Look at the results. Look at this, man. What was that? So remember, I just ran it a minute ago, and it was. Now it's 60%. Leetcode just like they show you anything here. Why is it 61% now? And it just showed me that it was lower. So now I beat everybody. I beat most people. Not everybody, but most people. 61%. So in time complexity. And then 80% in memory, which I expected because I'm barely using any memory. So yeah. Please let me know if any questions, any way you think you'll optimize this. The one thing I do want to talk through is I remember I was going to tell y'all about the time complexity. So for that, I'm going to look at the answer because I don't remember what it exactly it is. So this is solution, Yeah. So I think, my guy, I can't remember his name. He probably left now. But my guy that said that this is like a brute force solution. But yeah, because the input's super small, like we're kind of safely assumed that the brute force solution is fine. But yeah, first start, yeah, it says when you generate, and then somebody else mentioned backtracking, when you have to generate some group of letters and numbers, something like that, or combinations. Always think like backtracking algorithm in that case. It's always smart to think that at first. And I'm not gonna read through this because it's basically I think the same solution that I decided to do. See, they did they did some backtracking thing, which I don't get it. I don't get why they had to do that. Why they had to do this. Oh yeah, no, this is it's backtrack. This is the same thing I did. They just okay. So they do it a little different. I do the backtracking, but I use more variables here. More like store more variables. So they append the letter, go in, and then delete it out. When I just decide to pass the I did it a little different. I decided to I don't know why this is so different, but mine still works. But I think it's something. I'm trying to think of why you would care about the backtracking at this point. But maybe because it's not backtracking the path, string builder path, added combinations, phone digits at index. Oh, I know why. Because they're passing an index. Yeah. So that's why. I'm passing a whole string through there. They're just passing like an index and they're doing logic like a little bit differently. They're passing this index. I just decided to use the length of this, so I didn't need to backtrack. So I actually like my solution better. So yeah, the time complexity. Yeah, so yeah, this is what I was thinking. Time complexity is big O 4 to the nth power times n, where n is the length of the digits, which I did say that. And 4 in this expression is referring to the maximum value length of the hash map and not the length of the input. Yeah. So right? Because there are 4 combinations in each. There's 4 max combinations in each digit. So the worst case, if we had 7s and 9s, you know, you have like P, R, S, Q or whatever. And so, yeah. But I don't know why it's like, generalizer session where in digits. So the one confusing part is 4 to the nth power. I thought it'd just be n times 4, but it's 4 to the nth power. This is a really confusing time complexity. This is like, I know hard problems that time complexity aren't as difficult to figure out than this one. That's why I didn't know what it was. So this one is the time complexity for this one is harder than the problem itself. Because I still don't understand why it's 4 to the. I know that 4 should be in there but I don't understand why it's 4 to the nth power. But maybe somebody else understands that. And I missed all the comments because I scrolled up. Yeah, so I'm looking at the answer after I finish the problem. So please don't come at me like I never finished the problem or something like that. So just to wrap this up, I'm doing a problem called letter combinations of a phone number, where you need to find, based on a couple digits, you need to find all the possible combinations that are possible from the keypad here. And so I've already done the problem for people that are just joining. Did the problem, walked through it, talked about the time complexity, used a recursive function, which actually maybe you should call this maybe I just call this backtrack, since that's what they call it in their answer. I call it depth first search, but I guess it's not technically. It's like, to me, it's very, like, those algorithms, like, are really similar in, like, how they work. So I always, and then when I learned it originally, I learned backtracking, like, right after I learned depth first search, because it kind of, like, builds on top of it. And so, yeah, so I can call this backtrack. But I'm not actually backtracking, because I'm passing the whole string into the function recursively and using the length of it to drive my logic here. So I don't even need to do the backtracking that the other people were doing in the solution. So actually pretty cool. So I'm kind of just rambling now, but I appreciate people joining. Please let me know if there's any problems you ever want to see me do in the future. I'm not in school right now. I'm actually I have a full-time development job. I'm a senior engineer at a mid-sized tech company, team lead, and I just practice. I'm just practicing this stuff. You got to just stay sharp with this stuff. I'm not really actively looking to go anywhere right now, but I need to stay sharp with it. I actually interview people with questions like this, so I just have to stay sharp on it. And I think it just makes for good content. I'm just trying to help people out. I don't see a lot of people doing challenges online, but challenges are a big part of getting into tech as a developer. Sorry. So like, sometimes not a developer, it's the challenges for other technical jobs as well. So I'm just practicing. And then I'm trying to help people. I'm trying to just share content, grow my following, of course, grow my brand, but also just help people out. I mean, it's just free content, and people aren't sharing these challenges too much. I found this challenge on Leetcode.com. But yeah, please follow. You'll see more challenges like this. I go live at least 2 times a week, doing either coding challenges or doing just working on my own projects. I work on my React projects and React Native projects, and I just share them, and people find it interesting sometimes. And yeah, so just follow, and yeah, Leetcode. Can you see this? LEETCODE. If you're gonna be a programmer, like, you definitely need to get on Leetcode and start with the easy problems. And honestly, I would start with Leetcode a little bit, but I would find another resource. I would recommend is Algo Monster or Grokking, I don't know what the heck that term is, but Grokking the coding interview. Like, you need to learn the basics first. I tried it. I tried the other way. I tried to go learn a bunch of do a bunch of Leetcode problems, and I just wasn't getting anywhere. But once I went and learned the actual patterns, the algorithms, the structures, you start to learn that there's like consistent ways to solve all the problems. It's still hard. Some of these problems still have trivia type intricacies that are hard to figure out, but you know, once you learn the patterns, it does become easier. So I would recommend Algo Monster or Grokking, whatever it's called, Grokking the Coding Interview. Either one of those. And there's a bunch of other resources that are similar to it, so I'm not gonna say those are the only ones, but those are the ones I recommend. But yeah, so appreciate it. And I'm also on other channels. I'm on Twitch streaming, so thanks for people on Twitch. Thanks for people on Facebook, anybody on Facebook, and anybody on YouTube. I'm on Instagram and TikTok. I'm everywhere right now live. So if you are on one channel and you think you would like, if you prefer another channel to watch me on, I'm on all the channels. So you can go find me on your favorite channel to stream or watch or follow people. I also post random funny content and interesting programming content and tech content. So with that, I'm probably going to jump over here. It's getting late. People starting to fall off. I understand, because some people Friday night, people going out, and I'm sitting here doing coding challenges. And then people just tired from the week. So I'm sure people on the East Coast, at least I'm on the East Coast. And so I'm sure people are starting to tap out right about now. So appreciate y'all. This was a longer one, but I appreciate everything. People watching and commenting and everything like that. Have a good night. Appreciate it. M3CC. Appreciate it, man. All y'all have a good night, and I will see y'all in the next one. Appreciate it.